Welcome again. Today we look at topic 1 from IB Chemistry, Stoichiometry, looking specifically at how you determine the limiting reagent in a chemical reaction. Let's go in and have a look. Here we can see the problem involves a reaction between 100 milliliters of 0.1 molar hydrochloric acid and 5 grams of calcium carbonate, noting that our information is provided with 3 significant figures. We need to determine the limiting reagent and to calculate the mass that is unreacted of the other reagent. We also determine the theoretical yield of calcium chloride in grams and the expected volume of carbon dioxide. First, we must write the balanced equation. And here you can see that the balanced equation shows that 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid, producing a mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. Next, we determine the relative formula mass of calcium carbonate, referred to as the relative formula mass and not the relative molecular mass, for calcium carbonate is an ionic compound. After visiting the periodic table to determine the relative atomic masses of calcium, carbon, and oxygen, and then after multiplying oxygen by 3 for the 3 oxygen atoms, we determine the relative formula mass of calcium carbonate to be 100.09. Then, using this relationship, the number of moles is equal to the mass in grams divided by this relative formula mass. We calculate that 0.0500 moles of calcium carbonate are present in 5 grams. Next, we must consider how much hydrochloric acid is required to allow for the complete reaction of this amount of calcium carbonate. And once again, we consider this relationship that we determined from the balanced equation with the 1 to 2 mole ratio. But in reality, if we have 0.050 moles of calcium carbonate, then we would need twice as many moles of hydrochloric acid for a complete reaction. But we're only provided with 100 cm cubes, or 100 milliliters, of 0.1 molar hydrochloric acid. 1 liter, we would have 0.1 moles. So in only 100 cubic centimeters, or 100 milliliters, we would have 1/10 of that, which is 0.01 moles, significantly less than the 0.10 moles needed for the complete reaction. So we realize that with only 0.01 moles present, much of the calcium carbonate would remain unreacted, and the limiting reagent is hydrochloric acid. And with only 0.01 moles of hydrochloric acid present, it means that given the mole ratio, only half of this number of moles, with the 1 to 2 ratio, of calcium carbonate would actually react. Half of 0.01 is 0.005. And only 0.005 moles of calcium carbonate will react, or only 1/10 of what you have in the reaction vessel. So it means that only 1/10 of the 5 grams that you have would be consumed, leaving 4.500 grams unreacted. In keeping with this, we determined that only 0.0050 moles of carbon dioxide would be produced, from the fact that 1 mole of a gas occupies 22.7 cubic decimeters at standard temperature and pressure. Then we can determine that the volume of carbon dioxide produced is 0.114 cubic decimeters, the answer to 3 significant figures in keeping with the data provided in the question. And now, I would like you to complete the final part of this question, which is to calculate the theoretical yield of calcium chloride in grams.